Okay, I'll just give a quick overview of this thing. So there's this like really exciting direction where we can prove things from the real world on-chain. I guess an example of it is a project this gentleman is working on. Passports. Passports are they're signed by a public authority, which we can check the public on a public registry. They're public keys, and we can run circuits on the content. So we can prove things like over 18, nationality, things like that. Another example of this is ZK email, where we have a signed email by the domain, and we can run circuits on the content of this email, and then prove things. So we're able to prove things from outside of in our traditional everyday life on-chain. Another project that's in this direction as well, that's able to prove things from the real world, would be if we can prove website data. If I can just log into my online banking, make a transfer to Lance, and then prove that I made that to Lance, like that's like opening up Web 2 to Web 3. And this is really what this talk of it is about, is potentially maybe we can do it. Cool. So I'll start at the beginning with talk about zero math. I'll just go over the concept and how it all, the flow of it all, and then if there's appetite, we can get into the cryptography part of it second. Cool. So let's look at what happens in a website. The problem with websites, they're not signed by the server. What we have is an encryption. So when you connect to a server, the data going back and forth is encrypted, but it's not signed by the server. So let's look at actually what happens when you want to connect to a server, a website, what actually happens. So we have this this thing called the TLS handshake. And the TLS handshake consists of two parts. First of all, it's the asymmetric part, and then we have the symmetric. So the first part is you have a public key, the website has a public key, and you do something called a Diffie-Hellman key exchange, where you give it your public key, they give you your public key, and you are able to establish a common secret between you and the server. This secret is then, we are able to use it to do some encryption and decryption. So here so the first part, we share our public key, they share their public key, and we establish a secret, S. And then in the second part, so now this is the first part. Now the second part, we want to actually I want to send my login details to the website. So I take my login details, I encrypt it. And the encryption looks like something like this, like we want to encrypt. We take a secret, and this, and the details, which is the M, the message. And this produces a ciphertext, which I can send to the server. The server will decrypt it using the same S that we established in the first step, and the ciphertext, and they will get the message. So we have this. So we're now able to contact the server back and forth in an encrypted way, such that if people are watching, they're not able to see what's going on. Cool. Now, what is the problem here? If I want to prove to you, like if I want to tell you, hey, I contacted my online banking and I made a transfer to you for $1 million, but in reality I've done 1,000. And I tell you, hey, like this is the ciphertext, you can decrypt it yourself and double check. That's not going to work. That's not going to fly, because I could have just encrypted it myself, because I know what this S is. I could have just encrypted it myself. So you don't trust me, because I could have just done it myself. Cool. So this is where Tlsnotary comes in. There's this project called Tlsnotary. Actually, you can see the history of it in some Bitcoin forum in 2013. People were talking about it. And the idea is like, okay, we cannot prove. Let's take this TLS handshake thing, and let's see if we can introduce a notary, a third-party notary, that is able to notarize data going up and down, and then maybe generate a proof that, hey, I've actually done this TLS thing correctly. Cool. So,
can't you ask the bank to ask us the notary?
can I ask
Because
the bank?
the bank, you trust the bank because you're using their system. So can't you ask the bank to sign your verification?
Yes.
of the
If the
transaction?
bank signs it, if the bank sends you information that's signed, fantastic. In fact, like I'm looking at open banking APIs now, and there are optional fields of signatures, and maybe we can actually ask the banks to just sign it, and then we don't have to do any of this. Like, you're right. If it's signed, it's fantastic.
I think more generally, like the goal is to have some kind of like to be able to create like an agnostic third party that could authenticate, so that you don't, so that every service you're using, you don't have to convince them to create signatures, because most services are lazy and they're not connecting.
Yeah, but how are you gonna be sure that the notary is signing the right information?
Okay, well, let's look into it, and then we
Thank you.
can talk more about things. So we have a website, we have the same user, and we're going to introduce a notary. And is everyone familiar with the traditional form of a notary? What a notary does?
Like in
In the legal
yeah.
world, right. Everyone's familiar with this?
Yes.
Okay, cool. Familiar with this notary?
Kind of.
Okay, cool. So notary, like in the legal sense, like you want to do your marriage certificate or something, you go to the notary, they sign it. So you have this like, they confirm that you just didn't do it like in your home, like it's actually legit and legal, right? Like that, it's recorded somewhere publicly, somehow.
That's the theory, but yeah.
Yeah, like that's how. Actually, funny fact. I was looking at the notary history of the use of the word, and it was really popular in the 50s and 60s, which does make sense because we're probably not notarizing things these days. Like,
But I sign notary documents in my house.
Okay. So
Yeah.
you
Yeah,
notarized
yeah.
yourself.
Is that
No.
Is that legal?
No, obviously not. But what can you do? No, I mean I'm not the notary. The notary is saying that I signed it, but he's not in front of me, which is it fails the purpose of the notary,
Yeah,
right?
of course.
Yeah. It's signed in front of the notary.
Yeah, but it happens a lot in Spain. They will just give you the document like signed by the notary, and then just wait for your signature. Or you sign it and then they send it to the notary. But if you're not there, it's not technically legal. But
You can do it online
Cool.
with TLS notary.
Yeah, let's look at how this might work. So we've introduced this third party called the notary, and we want to do exactly the same steps, right? The TLS, remember, is two steps: the asymmetric part and then the symmetric part. So for the asymmetric part, what you can do is take this person's public key, the notary's public key, and you can take your public key as a user, and you can combine them together, send it to the website public key, so you send it to the server gives you the public key. So okay, one thing to keep in mind, the server doesn't know that a notary does exist, right? Like the server just sees you, right? They don't know that you're taking part in this elaborate scheme with this notary. So you contact the notary, say, look, I want to notarize some data, give me your public key. You take their public key, you take your public key, you combine it, and you send it to the server, and you do a traditional Diffie-Hellman key exchange with that, with a combined key. The idea is that when we come to the second part, which is the symmetric part, what we end up with is actually you holding a share of this. So this, let's say that S is what is the encryption string that we're using to the secret that the encryption key that we're using. You would be holding a share, and the notary will be holding a share, such that you cannot use it. You cannot actually encrypt data to a website on your own anymore, and you cannot decrypt data coming from the website anymore on your own. You need the notary to be with you. the notary is connected to your hip. Like you're doing every single cryptographic operation you're doing with the TLS, you're doing it with the notary.
But how is the notary verifying that you're doing what you're saying that you're doing?
Well, right now in the first step, we're not doing anything. We're just
Okay.
saying, let's
Sign it.
establish this S, which the website now has, and we actually neither of us have a full version of this S. I just have a share, the notary has a share, right? So this is the first step.
Combine and split. Okay. You combine the key.
You combine the
and
keys,
split it.
you combine the keys, and yeah, you combine the keys and you just send it to the website. The website comes back with a,
Okay.
yeah.
So in this case, wouldn't every website need a notary service for every user?
Well, what you're notarizing is not every website. Like the notary is just like every time you want to connect to a website and do some
In
notarizing,
the same notary.
you can use a notary. Like at the moment, we're just talking about a notary, like as a third-party kind of service.
Mhm.
Like this could be a network of notaries,
I see,
right? Like
I
this
see.
could be a network of notaries
Yeah.
if you want to decentralize it. But
Okay.
for now, like let's just assume this is an
one.
entity, like a notary entity,
Yeah.
a service, a notary service.
Okay.
Cool. So we have shares, and now what we want to do is be able to send requests to the website and come back from the website. That's the point. I want to send my login details. I want to get my balance from my online banking. So what you do is, this is the second part, which is like the magical part of this, is that we are able to, maybe I can show something here. There's a nice graph. Which is so okay, yeah, this is the how the so we have a server, prover, the notary. You take the key, public key of the notary, you combine them, send it to the server, and then the server gives you their public key. You pass on the public key to the notary, and then you do some funny stuff, and then you get the key, the encryption key from the server that they have, and then you have a share, and the notary has a share.
Wait, Mohammed, can you scroll to the top of the diagram one more time?
Yeah.
Or maybe full screen it.
Prover, verify.
Problem is if I full screen it, I lose the entry so I cannot do it. What did you want? Sorry.
I just wanted to see the prover verifier circles.
Yeah. What I wanted to show you that the interesting part in the whole thing is this part where how do we actually now, like you have a share, notary has a share, I have a share, and I want to encrypt my request, I want to encrypt my login details. So what you bring to the table is you have your plain text. The plain text here is your login details, and we have the key share. We want to calculate a function together. So is anybody familiar with the concept of garbled circuits? Okay, I'll just say something quickly about garbled circuits. Garbled circuits is like an old kind of cryptography tool in the MPC world. It's like been there for many years, and the idea is we want to be able to calculate a function with input from Alice and input from Bob, right? So each one brings their own input. We want to be able to calculate this function together, but without any of us revealing each other's inputs. Like, I want to bring my input to the table, you want to bring your input to the table, we want to calculate a common function, but I don't want to know what your input is, you don't want to know what my input is. What we would love to know, but the idea is that we can calculate this function without any of us revealing what we bring to the table. And this is what Tlsnotary works. We want to be able, the function in this case is the encryption of the request that we want to send to the server. So what we want to do is we want to do this technique, this garbled circuit technique, for the user. In this case, this is a user, this is the notary. What we want to be able to bring into the case is the plain text as a private input, and the share, the key share, and what the notary brings in is the share. And together, we're going to collaborate to produce a ciphertext that we can send to the server. which I couldn't have done on my own, but I could do it with the notary, with the collaboration of the notary. So this is what like this diagram just shows. Like you use the prover, you bring your key share, your plain text, you're able to together encrypt a ciphertext that you will send, which includes your request. The notary in this case what they can do is actually like, this is the first part where they notarize. Like that's the first part where they're like, okay, I can see this like this. Well, what you're doing really here is like you're not showing them the plain text. That's the cool thing about this. You're not showing them the plain text. They cannot see your login details. What you're providing is a commitment to this plain text. And what they're doing is they're signing this commitment. Like they're saying, okay, you definitely wanted to send this commitment to the server, and I can attest to that. And that will be useful later on when you want to prove to someone else that actually this is exactly the result that I got back from. Yeah.
What's the point of signing a commitment if we already use a key share? So like no one can generate, like no one can follow the protocol if the notary is participating in it.
Yes. I think the idea is that when you at the very end of this,
Yeah.
when you sent information to the server, you got information back from the server, like let's say your balance,
Yeah.
and you want to decrypt it, and now you want to prove to some other party that hey, like actually my balance is this. You want some sort of like you want some sort of proof, like the notary actually signed this. Like what are they signing? You need to show someone that the notary actually took part in this.
To connect the request and the response.
Sorry, but by having the transcript of this protocol and revealing this transcript, you already sort of proved that the notary was taking part, and because the notary was taking part, you cannot.
What do you mean by transcript in this case?
Like all the message sequence. So like you cannot generate a response to the server unless notary participates. Essentially, if notary participates, then it must agree. Like you cannot fake the message. Essentially, you cannot.
Yeah, you cannot fake the message that is going to the server, and you cannot fake the message that's coming back.
Yeah. So if you have valid transcript, then essentially you should be able to.
Yeah, maybe there is like actually if you show someone the full transcript of all the operations, then they will be certain you did that with the notary.
And then you can now not show it, but prove ZK on top of the transcript, and now you can get whatever.
Well, okay. The main problem with this whole notary system is that you cannot just ZK all the computations.
Yeah, after you. Okay, because too busy is too very heavy.
It's not just that. There's a fundamental problem here. Is that the notary, like the real problem is that you could be collaborating with the notary. Like you could be running the notary yourself.
Okay.
Right. So you could be running all ZK about all your computations and all this MPC stuff that you're doing with them. And if they happen to be collaborating with you, they can just give you their share.
But commitment doesn't help that.
The commitment doesn't help that. Yeah, the commitment doesn't help that. The commitment is just, what I'm trying to say is like the ZK stuff does not really add much to it. But the commitment is really just so you can hide the plain text, because you don't want to show the notary your username and password.
I see.
So you hide it, but you make a commitment to it. I say, look, I'm committing to this message that I want to send to the server. And then I guess the signature in this case, like it's there to be able to then later on verify things easily. Like, okay, I definitely saw this request and I signed it. I guess there might be a way to just pass on the CKP without the signature. Like that's a good point, maybe. Yeah. But there's a need to prove to some other person that you've done something with a notary. Yeah. Cool. So this is kind of I guess don't want to say anything else. Garbled circuits, encryption, verification. Yeah, I wanted to talk about verification.
Can we talk about decryption? So how
Yes.
does decryption work?
Yeah, actually, let's go down. So, the decryption is also like another garbled circuit kind of situation where we're both calculating. We need to calculate a function, the decryption function together, and the verifier brings their key share to the table. The ciphertext we just got from the server. So actually what the prover, like the user here is the prover. The user is getting the ciphertext from the server, and they're putting it on the table because the verifier actually the notary does not actually speak to the server. You're the one speaking to the server. So yeah, you provide their key share, they provide a key share, you have the ciphertext, and you're able to get out this plain text that only you can see what the notary cannot see. So you can see your balance, the 1 million, 1 billion, with all the private information on there, your username, your address, your date of birth.
I'm not sure, but if I remember, in multi-party computation, usually the output is public for both parties.
Yes.
So, and here the plain text should be private.
Yeah, I think what is actually happening here is that there is the notary at the end reveals something that allows the
Probably the 2PC is private key, another like encryption key, and then the encryption key is revealed to the party so they can encrypt the proper. You can do like double encryption essentially, and you use 2PC to hide the second encryption key, and then only like it's then revealed to the prover who can then decrypt the second part of the message.
Yeah.
Okay.
Yeah, I think what happens, like you're right, the output is public, and then the verifier is able to just give them at that point, because then it's safe to give them the secret. It's no longer a problem.
Yeah.
And then you can just decrypt it yourself. But okay, then why are we doing this key share thing? Receive the documentation in general, even with the math part, is really not great, like with the Tlsnotary docs. And I think it's worth like looking back at it again, and then doing it, like maybe helping them even to do it better.
So who is the approver?
Approver is the user.
A user.
Yes.
Verifier is who is verifier?
Verifier is the notary in this case.
Okay.
Like the terminology is just yeah.
Wait, but it says the resulting plain text is revealed only to the prover.
Yeah.
So is that like a part of the unique garbled circuit protocol that they use?
I don't think like this specific part is part of the garbled circuit. If my understanding is that this is not, and this is something you do after, like you just receive the shares and you can just decrypt it yourself. But I think what it means is that the notary is able to see the ciphertext and also sign it again, like say, okay, we definitely got this ciphertext and it's legit ciphertext, and then sign it, and then after that it's fine, and then they can give you. So you still need to like show them the ciphertext. You still need this step, so that they can notarize it and then reveal to you afterwards. Like once they've notarized the in and out, that's it, man. Like you can do whatever you want. Like you can take the share, and the secret from the notary, which is the secret share, the share key. In fact, the way to think of this notary's private share is just it's an ephemeral share. Like it's used only for the duration of the request. Once the request is done, we're gone.
Like a session.
Yeah, it's just like a session. Yeah, and over one request.
I see. Okay.
Yeah, I was gonna show it to you actually. Would you guys like to see it?
Yeah, yeah, for sure. Why not?
And then after that, we can dig deeper into garbled circuits if you guys want.
Yeah.
So we had a Twitter page here, and I don't know how many of you looked at the console part of the browser, but we will have like a bunch of like requests going in and out, and the Tlsnotary has an extension here, which they've made it really easy, and you can see the requests here, right? These are the like if we saw like what 42 there. If we like 42, if we refresh this, we will see a bunch of extra like they're going up. Right, these are all requests that you need. These are all mini requests going back and forth. Blah, blah, blah. Cool. So what we can do is take one of these requests. Let's say like we wanna prove that I own a Twitter username to someone, and this is so I take this request. This is just a setting request, which probably has some of the details we need, and all of like I need authorization to be able to contact my Twitter.com like page, right? So I need these things, but these are all private information. But this is the request that I want to notarize, and you can choose to notarize. And then all the information is hidden, right? Like you can hide everything. But you might want to like disclose that you like this is a twitter.com thing. You might want to reveal your username like here, like so. Okay, this is also all, but I can just hide it all, and I can keep this username M38MAH, which is my username, and then everything else gets redacted.
Interesting.
And then I can press notarize, and it will just send it to the notary server. And I mean, I don't know why it's taking a while, but it might take a bit. But I've done it before, so we have a proof, which is something you can give to someone else to prove to them that they've yeah.
So it's a proof that your
It's been
account
notarized.
on Twitter
Yes.
has made this certain request.
Yes. Well, it's a proof that actually like this M38MAH username,
Yeah.
twitter.com. Like I think we can see twitter.com. I should be able to see my username as well somewhere.
And how do you avoid user injections and spoofing from there? You cannot spoof it from the.
Spoof who? Who wants to spoof who?
Like, for example, I wanna say that I own Elon Musk Twitter and I change some detail and.
Ah.
Tillis
Yeah.
products.
It should not work because what you send to the server will, when it comes back, like, it will not.
Yeah, because TLS essentially, like what TLS, it trusts that you have a connection with the Twitter, but then because you cannot change the messages in it because the notary has the other key. And I assume, like this was my question. So I assume all the connections are already going through the notaries. Notaries already helping compute all the connections, right?
You're helping to compute, but the connection to the server is not going through the notary.
I mean, like it's like for every request that's
Yes.
done, it's like you don't need to press it; it's automatically being like notarized and going back. So here you just generate a zkey proof.
Yeah.
So like essentially, whenever you go to Twitter,
Yeah.
notary will see all 153 requests
No, they will not.
instantly.
They will not.
Oh yeah, your client will make 153 requests to the notary to compute this shared secret.
No,
So-
they'll just do it for the request that you need.
But it's already done.
No, it's not done.
I just saw like the Twitter page is loaded, so I assume all requests have already happened. How do you
Yeah.
post factum to it?
Yeah, it's already loaded. Yeah, you're right. Like I was wondering about the same thing, but I think it's like you.
It's
It's,
a new request. So it's just the new request, just
Okay,
like
so
you
you
are
just-
loading
okay.
a new web page, I guess.
yes, you're loading a URL. But I think like what this these requests are like what's happening here.
But that request is stored there, right? You're taking all the information from the request parts of the browser.
Yeah.
Remember
I'm
it.
going to a very specific request that I want like to notarize. I'm not notarizing everything.
No, I know, but what I'm
Yeah.
worried about is like if you modify the information locally, because if it doesn't go through the notary, how can they verify that data is not tampered with?
Okay, you can tamper. Let's say you tamper. Let's say
Yeah.
you put a wrong login details for your online banking. Like you're gonna send it, and something's gonna come back that's rubbish. Like you're not gonna be able to prove.
But the notary is gonna sign it nevertheless,
Fine,
right?
it will sign it. Yes, it will sign it going up. It will sign the ciphertext coming back, but you're not gonna be able to prove like the balance that you have.
But I don't know. I still.
Yeah.
Sorry.
I understand.
Worried.
I understand. I roughly maybe understand where you're.
I think that content is related to some signature from the server. If you change that text, it
There's no
doesn't
signature.
match.
There's no signature from the server.
Yeah,
It's
but
just
the
encrypted.
notary.
Encrypted, right?
Yeah, and encrypted.
But the notary is trusting your local data. That's my issue.
No,
Because
but-
the data is not going to the notary. It's not going through the
Yeah.
notary. You're sending to the notary because it's reading it from your.
No. So the server. So as far as there is a sniffer that listens to all the connections, and
No,
then
you're sending it to them.
Okay,
You
good.
notarize it, right?
Yeah. There's just so.
I don't know. I'm asking. That's what I'm worried.
You need both
Sends
to
every
decrypt
request
the
to
content from
to the
website.
verifier. But the prover cannot cheat because it's been encrypted with the private key of the verifier too, so it cannot change the data in plain text. The prover.
Well, I mean, you can put whatever you want in the request, right? Like the notary cannot know about it. what you wanna like. The question is, how do you do the verification with a third party later on? That's the question. I think that's interesting. It's like, let's say I send some rubbish request, I got some rubbish response, and then I want to prove to you that actually my balance is $1 billion. But actually, like, it's not. I cannot show you anything that says $1 billion, right? Like, I couldn't have cheated in that way if the notary is honest. So the notary is just running a server, like you're running a server on an API that I can just call whenever I need to notarize something. And what you do is like you establish a WebSocket connection with them, and you're doing shit ton of like back and forth cryptographic, like you're sharing stuff, come back. Like even when you do the encryption, you're also calculating the MAC on top of the encryption. The MAC is like the message authentication code. So which is every time you encrypt something, you add this MAC so that the other party can see that it's not been tampered with in between. So you're even doing the MAC with the notary as well. You're doing a lot of
What
cryptography.
if you're using the randomized MAC address?
Oh, I don't know.
Okay, so
I
it
don't
might
know
be
anything
not
about it.
possible to do it then.
What do you mean randomized MAC address?
So there are there's software that like
Wait,
for-
there's
for-
different messages.
it's not the same
Mac,
Mac
two
as
different
the
Macs,
Mac
cryptographic
address.
Mac and web.
Okay.
The,
interface Mac.
you're talking about
Mac
the actual
address.
physical.
Yeah.
No, it's a different one.
This is the Mac as in HMAC, like in
Mhm.
TLS.
Yeah, it's the message authentication code. Like every time you encrypt something and I give it to you, like on the other side that you encrypt it, I add this MAC so that you can use it to double check that this has not been changed during on the path.
Yeah, I'm curious. So if you go to request, there is an image request, right?
And
So-
the image request. Would
Yeah.
you-
Does it take longer to do files?
I don't know.
Or is it possible even to do files?
Yeah, I mean,
Because I imagine
which
I
one is
downloaded-
files though? Like here, like
There is image media,
Ah.
next to the bottom. Yeah.
yeah.
But like imagine downloaded gigabytes of data when a proof came from Facebook.
Hmm.
Can I do this? Maybe you try.
Yeah, I mean the thing is that I don't have the right settings right now.
Because I
but
might
we
need this
can
for my
quickly do
use
it.
case.
We can do it. We can do it quickly. See if it works. Let me just put the right settings. Let me get the exact. 'Cause I was trying to run it locally on the local.
Then as for request, I understand like you can do it blank, but then if you notarize the request, you redo it. But then when this time it comes, it doesn't go directly to a computer. It stays there. It goes to your computer and then to notary at the same time. Like some part of it was notary, so that you can actually decrypt it, and then like some magic happens that prevents you from manipulating the original.
Isn't the back and forth only the commitment?
No, like you need to do 2PC and 2PC is usually a lot of back and forth. And I was actually, because there is, if anyone remembers, there's a strong, like there's witness encryption, but there's even a stronger encryption which allows you sort of to create a circuit that has a secret but can do computations like trusted execution environments.
It's like IO.
Or, but by the way, like on iPhones there's secure
Like a
enclaves.
secure enclave, yeah.
And we can sort of put this stuff into the secure enclave, and we don't need to do a lot of back and forth because it's just one communication. You could send it to the secure
Mhm.
enclave, it checks it, and gives
So
you
your
back.
enclave is your notary.
Yeah, actually, like, it might be, so it's one thing I've been looking at, it might be possible to do TLS from the secure enclave.
Yeah.
Because like the secure enclave APIs, like they have like the right like signatures and everything, like ECDSA. But the issue seems to me that like if you want to encrypt a large amount of data, you cannot do it from the secure enclave. You just have one API to do the signatures. So, like even if you have the Apple secure enclave, if you like jailbreak your iPhone, you can still read
Really?
the memory.
Whoa.
Like you know what I mean? Like you cannot read in the secure enclave the private key, but you could like read the memory of all of the like
interactions?
yeah.
But that's not a problem.
Um,
As long as the secret key is secret. And I know there's another problem with Apple secure enclave because it's not Turing complete, so you cannot do all of the cryptography there. Like they essentially
Yeah.
expose you some of the operations.
Yeah, I think you can do like 2 or 3
Yeah.
different things, like really.
But what I was thinking of is essentially there's a cryptographic primitive which I forgot, but essentially allows you to do secure enclave with pure cryptography.
It's like IO indistinguishability of enclaves.
Yes.
But
That's
it's,
one.
it's hard to do. It's considered.
Yeah, for some reason I thought garbled circuits were exactly this, and then essentially you don't need a notary because you just spin up this.
Yeah, if you have IO, you can
IO.
do crazy things like this trustlessly because then you can
Yeah.
literally just have a smart contract holding
Exactly.
the symmetric key and doing ECDH and everything.
Yeah.
One thing I wanted to ask is theoretically, let's say you wanted to share data with the notary.
Yeah.
For maybe the notary stores all your cookies, right? So that you don't have to. It kind of acts like as representative to the website on your behalf. Could you do it that way?
So you
Where
want
you
you
just
want the
share-
notary to be in the middle between you and the server.
Exactly. Yeah.
Why would you want to do that?
I mean, just theoretically.
I don't know, but like, don't you like? Yeah.
I mean, you'd have to share your information with the notary for sure.
Yeah. Well, I mean, yeah. I mean, I think like who sends to the server is not a big deal. I
Yeah.
guess like ideally you would want the user to be doing it. Like you
Yeah,
don't want
exactly.
you don't want these extra dependencies in terms of like censorship resistance or like stuff like that. You just
But
want to be
rather
able to
than
do
doing it together, what if you could do it? You know, the notary kind of represents your presence on the web.
There's like those guys that reclaim protocol, and they're
Yeah.
not using like Tlsnotary, but basically they're kind of doing what you're saying,
Yeah.
is that having like proxies between you and the server,
Yeah.
and they are attesting to it. So it's not really like the same system, but the end goal is the same of like attesting to TLS data. But now you get new trust assumptions, like you gotta believe all those proxies the requests are coming through.
Exactly.
And they will be able to see the data as well, right? Or is it passes encrypted?
I don't really know the detail of how they're doing it.
What is the project?
Yeah, it's not still not working, but it might not be to do with the image, it might be to do with the notary server running on the PSE, because PSE are running a server.
Really?
Yeah. Tlsnotary is a PSE project, so they're running these servers as public, but you can run them yourself. Yeah, I was, but you can see I've been trying to play around with local host. Yeah.
So I'm waiting for them to make this server also decentralized, like create multiple peers.
Well, that's actually what I'm working on, and Florent is also like, we're kind of like helping like, on the ideation of this, like the idea of decentralizing the notary. So the design we have right now is to ask the notaries to stake something on L1, and then we're just ask like what you do is then a single request, you do it with n number of notaries. And then you need like 2/3 of them notaries to sign, and then on-chain will just accept it. So you need a 2/3 majority for the request to go through. And that's kind of the idea of how we're like looking at decentralizing the notary. But if we can decentralize the notary such that instead of here where you have notary API, you just put like network.a thing, and then you can use that on-chain. I mean, that's like that's the dream, right? Like you can then genuinely prove like online banking stuff on-chain. You can prove.
That's another thing I wanted to ask. Mina came out with this HTTPZ protocol where they include I think it's a ZK proof along. I mean, I didn't read into it at all. I just saw them. It was like a tweet storm. I'm like, oh, that's pretty cool. Have you?
Right. I don't know. I haven't seen it. Like actually.
It might be something that is.
Maybe like
I'm
share it
not
on the thing, and then you
In the Telegram?
Yeah. And then
Yeah, sure.
I'll also share some links in this. What do you guys think? Is that good, or
It's
should
lovely.
do you want to do like some? Do you want to look at garbled circuits and things like that, or like or should we just move on to something else, or like, should we move to a second speaker? I don't know. What do you think, Keisha?
Should we do speakers next?
Yeah.
We'll save some time.
Sorry for interrupting you so much. I'm just curious.